Hello and welcome back to another video. Today we're going to be doing number of longest increasing subsequence. And so this is pretty much a follow-up to the problem that's called longest increasing subsequence on LeetCode. And it's a very popular problem and I would definitely suggest you do that first. And I do have a video for that and I will link that in the description below. But in this problem, we have a variant of that where instead of returning the longest increasing subsequence, we need to be returning the number of longest increasing subsequence. So if there are multiple subsequences, then we need to be returning that number that are the longest. So let's go through our stuff. So in our first example, we have 1, 3, 5, 4, 7. And we're basically trying to figure out like what's the longest subsequence and how many are there. So we have one subsequence of 1, 3, 5, 7. And then we have another one, 1, 3, 4, 7. Those are the two longest and they're both length 4. So we need to be returning 2 here. Okay, now for the second one, we have 2, 2, 2, 2, 2. And so for that, that's each one of these is a one length subsequence. And so the longest subsequence in this is 1. And we need to be returning 5 because all of these are one subsequence of length 1. So we need to be returning 5. All right, so let's get an intuition on how we actually do a problem like this. And then let's figure it out, right? And so what we're actually going to do is we are going to do another example, though. So what we're going to do is we're going to take an example like this. We are going to take 1, 1, 1, 2, 2, 3, 3, 3. Okay, and this is going to help us demonstrate like why, like what we're actually doing here, essentially. Okay. So, like, where do we begin, essentially? So, what does make the longest increasing subsequence? Well, it's going to be a subsequence that's increasing, but how do we actually figure that out? And so for my previous problem, let's actually start off with this. Let's actually start off with this right here. And then we're going to be deleting that and move on to this top one. So let's just start off with this 1, 3, 5, 4, 7. And now let's just change our question to let's just get the longest increasing subsequence here. Not like the number of them, but just like what is the longest increasing subsequence. How do we do this? Well, it's going to be pretty straightforward. So what we're actually going to do is we're going to take an array here, and we're going to initialize every single number to 1. And then we are simply going to go through all of these. And the thing we're going to do is we're going to loop through all of the numbers before the number we're currently at. And just say, is that number smaller? And is that subsequence longer than the one I currently have? So let me show you what that's going to look like. So for like this number 1, we're going to say, okay, are there any numbers before 1? No. So we're gonna skip that because there's nothing there. Okay. For this 3, are there any numbers before 3? And what's their longest increasing subsequence? And is this number bigger than the other number? So let's take a look. So for 3, we're going to check 1, and we're going to say, okay, well, is 3 bigger than 1? Yes. So then what's the length of the longest increasing subsequence with the 1? It's 1. So if this subsequence is with a 1, well, 1, 3 is a subsequence, right? So that right there is going to be a bigger subsequence. So then for 3, we can actually make this a 2 because we can use the one with a 1. Now let's go to the 5. So let's delete all this. And let's go to the 5. And once again, we're going to check everything before, and we're going to say, like, what's the biggest subsequence we can get? So we're going to check the 3, and that is length 2. Is the 5 bigger than the 3? Yes. So whatever subsequence ends with 3, right, whatever is over here, we can just add a 5 to the end. And that'll be the length of that one plus 1. And so that's going to be 3. And then when we check, we can also check this 1, but this is only a 1 length subsequence, so then this one would be bigger. So we're going to want to select this one. Okay, and this is pretty much how to do the longest increasing subsequence, not the number. And then we're going to see what changes in the number. Okay. So now we're at this 4, and we're going to check other numbers. We're going to check the 5. So the 4 is not bigger than the 5, so we can't use that. But we're going to check the 3, and clearly we are going to use the 3. So the 3 is length 2 subsequence. So we're going to use that, and we are going to add 1 to that. So it's going to be length 3. Then we're going to check the 1, and the 1 is only length 1. So this is only going to be 2, and we're going to want to maximize this number. Okay. Now for the 7, we're going to check the 4, and we're going to say, oh, there's a 3 there. So let's just use that and add 1. So for the 7, we're going to have 4 here, right? Because if this is length 3, then we can just add a 7 to the end, and now this is length 4. Okay. Now we're going to check over here. It's length 3, so it's the same, so we don't need to do anything. And we're going to check over here. It's 2, so that's smaller than what we have because now we'll have 3, so we don't want that. And finally here, we're going to have 1, so we're going to have 2, so we don't want that. So finally, we have this array of 1, 2, 3, 3, 4. And now our longest increasing subsequence, we can just take the max. So how does this problem change when you want all of them? And so let's actually look how that changes when we want all of them. So we're actually going to write this 1, 3, 5, 4, 7 down over here, and then we're going to do this big thing later on. Okay, so for this 1, 3, 5, 4, 7, once again, we're actually going to keep it here, but now we're gonna redo this. So we're going to make another. We're actually going to let's just delete this. Delete this now that we went through how to do all that. So let's draw another one down here. Same thing with the ones. And like, what's the difference? Well, the difference is we might have multiple subsequences that are the same length, and we need to keep track of that. So we need to slightly change our algorithm to where if we have a subsequence that's the same length, we need to figure out like how many were there, right? So instead, what we're going to do is we're actually going to change this. Instead of this, we're actually going to have arrays of 2. So let's actually take this, delete it, and let's actually show you what we're going to do here. So we're going to have arrays of 2 numbers because we need to keep track of what's the longest subsequence and then how many of those do we actually have, right? So we're going to have 5 arrays of just 1, 1. So 1, 1, 1, 1, 1, 1, 1, 1. And it's going to be just a slight modification to the other problem, except now we're just going to maintain a count of like how many of these do we have, and then once we find the longest one, we can just add up all the counts of however many there are. Okay, so we're gonna do kind of the same thing, and let's follow along here. So for the 1, we're gonna go over here, and there's nothing there, so we can't do anything there. Now for the 3, we're gonna check, is the 3 bigger than the 1? Yes, it is. Okay, well, how many subsequences end with 1? Right? And if the 3 is bigger than the 1, that means we need to update that biggest subsequence for the 3. So for this 3, the biggest subsequence so far, so we're going to write this down. So index 0 is going to be length of subsequence. Index 1 is going to be count of subsequences, right? So like this is saying that the longest subsequence is 1 and there's 1 of them. Okay, so anytime we find a greater one, then we're going to reset our count to 1. Because let's say our subsequence is length, or we're not going to reset our count to 1. We're going to reset our count to whatever the count of the one that we found was, right? So let me show you how that's going to work. Okay. So for this problem, we're going to go over here. We're going to say, okay, well, 3 is bigger than 1. So this is a subsequence of length 2, right? So we're going to update this to 2. And then we're actually going to say, okay, now that we updated our subsequence, well, how many of subsequences were there that ended with 1? Like, let's say our thing was just like 1, 1, 1, 1, 3. Well, if there's like 4 subsequences that ended with 1, we're going to have to, update that. And so what we're actually going to do is we're going to take, if we update our subsequence, we're going to take the number that the other one had, and we're going to put it over here. And so because this one only had 1 subsequence, we're going to have a 1 here. Okay, now for this 5, we're going to go to the 3, and we're going to say, okay, so is 5 bigger than 3? Yes, it is. So that's a bigger subsequence because our subsequence is only length 1 so far. So we can make a subsequence of length 3, so let's change that. But how many of them are there? Well, how many subsequences of length of that ended with 3 were there? Where there was only 1. So now we're going to have 1. Okay, now we go to the 4. Or sorry, and then for the 5 we're going to go to the 1, and we're also going to check that as well, right? How many are there? But also the biggest subsequence here would only be 2, so we don't want that. Okay, now we're going to go to the 4, and we're going to compare to the 5, and we're going to say, okay, well, how many subsequences, or sorry, can we even use this? No, because 4 is smaller. So we're going to go to the 3, and we're going to say we definitely want to use this. So how many subsequences end with 3? Well, it's only 1. And so then we're going to update the subsequence for 4 to be length 2. And then there's only 1 of them because there's only 1 over here. And then we're not going to want to use, this needs to be a 3, right? Because the subsequence that ends with 3 is length 2. And now when we add a 4, it's going to be length 1, or 3. Okay, so we're going to delete this now, and we're going to go to the 7. Okay, so for the 7, we're going to check the 4, and we're going to say, okay, do we want to use the 4? Well, yeah, because the 4 is a subsequence of length 3, so now we can get a subsequence of length 4. And how many are there? Well, there's 1. So we're going to have 1. Now, what we're going to do is we're going to check the 5, and we're going to say, okay, well, is that going to be important? Well, yeah, it is, because for the 5, that is also length 3. So if I use, dot dot 5 7, dot dot 5 7, this is length 4, and we also want to use that, right? So we want to use this subsequence and this subsequence. And so here, what we're going to do is we're going to say, okay, well, we're going to want to use the 5, because that is going to be the same length as the current one we have. So if the one we found is bigger, we're going to want to use that. And we're going to want to update our count. We're going to want to essentially reset it to the one we found. But if the one we found is the same, we're going to have to keep adding to our count, right? Like, if we can keep using multiple numbers to make the same length subsequence, we need to keep adding all those. And so we're going to ask ourselves, okay, well, how many subsequences ended with a 5? Well, it was 1. And we already have 1. So we have 1 plus 1, so we have 2. Okay. And now finally, then we check, okay, what's our longest subsequence? Well, remember, the length of the subsequence is the first element in all of these arrays. And so what's the biggest one? Well, it's a 4. And so now we need to just go through all these arrays, check every subsequence with length 4, and see how many counts there are, and we need to add them all up. So in this case, it would be 2, and that would be the answer. And so let's write down our steps one more time over here, and then we're going to go do this tougher problem. So we have two things that can happen. So one, if our subsequence needs to be updated to a bigger one, we update it, and we take the count of the one we updated from. Okay. Step 2, if our subsequence is the same length as another one, we need to add the count from the other one to this one, right? So this is 2. If we need to update our subsequences, then we're going to reset our count initially, or essentially. And if we're going to if we have multiple things with the same subsequence length, then we need to keep adding to it, right? So let's say all of these were subsequence length 3, right? All of these. Then we would say, okay, for the 7, we could use the 4, we could use the 5, we could use the 3, we could use the 1. And so we need to add all these counts up. So we'd add like 3, 3, 3, 3, and now we'd have 12 in here. And so this is kind of what we need to do for this problem. So let's just try to go through this problem now, knowing what we have. Okay, so we're actually going to copy this, and we are going to give us some more space up here, and let's try to go through it. Okay, so we're going to do the same kind of thing, essentially. Might be a little long, so maybe I won't do every single step, but let's see how it goes. Okay, so we're going to do the same thing where we make these arrays of 1 and 1 initially. So how many do we need? We need 3, 5, 8. Okay, so 1, 1, 1. 2. I think I can actually copy these and just do this a little faster. And there, here. Make this a little. Let's make this a little bigger so we have space. Let's delete this, and let's copy it and put it over here. Over here, and let's finally have a closing. Now let's just delete this. Okay. So let's go through our steps again. So for this one, there's nothing, so we don't need to do anything. Now for this one, remember it has to be strictly bigger, so we can't use that either. And we can't use that either. Now let's start with a 2. That's where we kind of start doing things. Okay, so for the 2, we can use this one, right? And so that would be a subsequence of length 2, and it would be count 1. So we can use this one, so that would make a subsequence of length 2. But we can also use this one. And so that's another 1, so we need to add to our 2. So now our subsequence is going to be length 2, and we can also use this one. So it's actually going to be, subsequence length 2, but we can use 3 different ones, right? So we can use this one 2, this one 2, and this one 2. We can use all of those. So because we use each one of the ones, we need to take all of their counts and add them up, right? So there's a 1 and a 1 and a 1, and that's why we made it a 3. Okay. Now for this 2, it's going to be the same thing, right? We can't use a 2, but we can use the 1s, and so that's going to be the same thing. It's going to be 2 and then a 3 here. Now let's use the 3s. Okay, so we're gonna go over here and we're gonna say, okay, well, we can use this one for sure, right? So what's gonna be the answer there? Well, it's gonna be 2 plus 1, so that's going to be a subsequence length 3. Right, subsequence length 3. And how many were there? Well, there were 3. Right? So there were 3 here. But look, we have 3 here, but we have 3 here as well. Right? So we need to be able to use both of those. So we need to use these, and we need to use these. So it's going to be 6 total now. And here there's going to be 6 as well with subsequence length 3. And here there's going to be subsequence length 3, 6 as well. Right? Because this 3 can use both of the 2s because they're the same length, and this 3 can use both of the 2s. Okay, so now this is going to be our output. And now, what's our longest subsequence? Well, it's length 3. How many are there? There's 6 here, there's 6 here, and there's 6 here. So there's 18 total. And so now you see how you need to keep adding these counts. And if you, anytime you reset, you're going to reset the count. But if you have a subsequence that's the same length, you need to keep adding these counts. And then finally, you just go through your nested arrays. You find the biggest subsequence, and you add up all these counts. All right, so now we have enough to be coding. So let's do that. So we're actually going to keep track of the biggest subsequence as we're doing this. So we're just going to say like longest equals 1, and we're going to keep track of it as we're doing this. Okay, so we're going to make our DPs. So we're going to say, let's make it 1, 1 for I in range length nums, right? We're just going to make a bunch of 1, 1s. And how many is it going to be? It's going to be you know, the same length as this nums here. Okay. So now we're going to loop through our DP. And remember, we need to loop this way. And then for every number, we need to check every number before it. Right? So we're going to say for I in range length DP. Then we could say for j in range I. Because we only need to compare this to every single number before it, right? Like in our picture. Like if we're at a 3, we're going to need to compare it to this, 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 this. All of those. This is essentially an n-squared algorithm. Okay. So now we have 2 cases, remember? So for our first case is, so first we need to actually check, can we use that number, right? So if nums I is strictly greater than nums j, that means we can use that number. Now we have 2 cases. Do we have a bigger subsequence, or is it the same? So let's go for the bigger one first. So if dpi 0, this is going to be the length of the subsequence, is less than dpj 0 plus 1, meaning like in this example, like let's say we go over here, the subsequence length is 2, so then we would add 2 plus 1, we'd have 3, and we are asking, is the length of the subsequence that ends with this 3 that we currently have, you know, smaller than 3? And if it is, then we need to update it, and we need to update the count, and we're going to reset the count here. So we're going to say dpi 0 is going to be, we're going to make it equal to dpj 0 plus 1. That's the length of the subsequence. Now we need to take care of the count. So dpi1 is going to be dpj1, right? Whatever we took it from, let's just use that count. Now we have the other condition where they're the same, and so this is going to be very similar code. So let's just copy some of this. So now if these are the same. So if these are the same, what do we need to do? Well, we actually need to update our count to add the count of whatever we found, essentially, right? So if they're the same, then we need to update the count to add the count of whatever. We're not going to reset it because we're not changing our subsequence length, but we are going to update our count. Okay. And so finally, we are also going to check for this longest subsequence. And so the only place we need to check is if one of these happens, then we actually need to check like what's our subsequence length now. So we're going to say longest equals max of longest and dpi 0, which is going to be the subsequence length. Okay, so we can actually do that here. We can actually put that in here, I believe. We don't need to do it when we add because this is not going to change the length. Okay, so we can just do it here, only when we increase the length. All right. Now what we need to do finally is we have our longest count. Now we need to add up all of the counts, essentially, right? Like we have our longest subsequence, so let's say it's like 3 in this case. Now we need to add up every single count where the first variable is 3. And so we could actually do that with a sum. So we can say like just a 1-line thing. So we could say like, okay, let's just take I1. Right, so let's just take I1 for, let me see here, this doesn't need to be like this. Okay, let's just take I1. So this whole thing needs to be a list because we're going to sum up a list. Okay, let's take I1 for I in DP if I0 equals longest. Too much JavaScript. Okay, so we're essentially what we're saying is let's add this I1 to the list. Let's add this count to the list if the first element equals the longest, right? So in case our longest is 3, so we're gonna say like, okay, is this 3? No, we don't need this element. Is this 3? No, 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 no. And then finally here we're gonna have yes, and we're gonna have yes and yes, and so our list is gonna look like this, and we can just sum that up, right? So we're essentially just doing that in one liner. You can have an if statement where you do some other stuff, and that'll work as well. So, but it doesn't cost us anything to make this list because we already have and then we already have a list as well, so it's still going to be n time, and sorry, it's going to be n space. Okay, so we have a solution. It works. Now let's think about the time and space here. And yeah, I kind of wanted to do more bottom up because I feel like most of my problems have been top down memorization. So I think it's good to learn bottom up, and not in this case, but in some cases, bottom up is actually a more efficient algorithm. And it's good to know both. So I think if you are good at memorization, I do think it's a little bit more straightforward than practice on bottom up as well. For this problem, bottom up is just a little bit more intuitive, but in general, I'm probably going to start doing more bottom up just to practice both. Okay. So for our time, we are going to have this is going to be n, and this is going to be n again. So it's n squared essentially, and then this is all just like O of 1. So our time is going to be n squared, where n is the length of nums. And then for the space, we are just storing 2 numbers for every single number in length nums, right? So that'll be like 2 times n, which rounds down to O of n. All right, so that's going to be it for this problem, actually. And if you liked it, then please like the video and subscribe to the channel. And I will see you in the next one. Thanks for watching.